One of the more important tools we have to work with when we're developing source code, especially in the Unix environment, is a debugger. So what I want to do is demonstrate to you how to debug a very simple program using the Eclipse environment. All debuggers generally have the features that we're going to be showing here with Eclipse. How you go about doing them tends to be a little different, but the basic functions that I'm going to be showing you here are present in all mainstream debug environments. So let's take a look first at the program that we're going to be debugging. So our program here is pretty straightforward. We have a main here that we initialize a couple of strings to be null here. And we have another string that's got a max string length. We enter a string from the console, read it in like so using fgetS, where we can read up to the length of this buffer. So fgetS basically takes a pointer to where we want it to go to, the max length, and then a input that we're going to read from, which in our case is going to be standard in or the keyboard. We convert it to uppercase, we convert it to lowercase, and then we print out those 3 values to the console, at which point we end the program. Nothing really too complicated. Let's run it here and see. So I'm going to run 2 caps demonstration, and I'm going to type my string in. This program will not work. Ooh, segmentation fault. Bad. We don't like those. Segmentation fault is basically the Unix environment telling us there was something wrong somewhere with memory. So either we had a variable, a pointer that pointed to something that was invalid, a null pointer being dereferenced, we went outside the bounds of an array, we tried to write something that we only had read access to. Any one of those types of things can potentially give us something along the lines of a segmentation fault. That's not good. We don't like segmentation faults because it means our program's not working. It's crashing. So if I highlight my executable and go up here and debug it as a local C or C++ application, what will happen is a couple of things. First off, we're going to start the program trying to run. It's going to ask us then if we would like to switch to a different perspective. So the debug perspective changes the view a little bit. It gives us some different things to see. And it allows us to now look at the code in a different manner. By default, when you debug programs in Eclipse, it will stop at the first executable line inside of main, which is very handy. We can undo that if we wanted to, but it starts and basically stops immediately so that we can start single stepping. Now on the screen, what you're going to see is a couple of different things. First off, you're going to see right here the source code that we had in our C view. You're going to see over here on the right, upper right here, essentially the variables, the types it has, and the values it has. Okay, so what I'd like to do is now single step over some code here. So I'm going to use the step over, or F6 on my keyboard here. I'm going to step over each line as it goes. So you can see that this became 0 because that was null, or was set to null. That was now set to null. I'm going to print out fgets. So please enter a string on the console. This will break. And like so. So this will break is my string on the console. We can see now that our initial string says this will break like so. And what I'm going to do is I'm going to now step over again, or F6, the caps string. Bang! We got a seg fault right in there. In convert string, oh, this is telling us exactly where the segmentation fault is occurring in this case here. And at this point, the program is kind of broken. If I try to continue on, eventually it will terminate, so on and so forth. So we know there is some sort of a problem. So what I would like to do is switch back over here to this main program here. The segmentation fault occurred inside of this method. So what I'm going to do is I'm going to take and put a breakpoint inside of this method, right near the top of it. I can put my breakpoint anywhere. That's the point where we're failing, so I'm going to put it there. And now what I'm going to do is I'm going to debug this again. Whoops. Got to select the right binary. I'm debugging it. I'm going to do one thing a little differently when I switch perspectives here. Instead of single stepping, though, what I'm going to do is I'm going to step on this, or press this resume or F8 button. That will cause the code to keep running. So I can type in, this is broken. So we ran, and you'll notice that we stepped all the way through to this breakpoint that I set right here. And this line, basically what it's doing is setting CSRC, C destination, current source, current destination, to be the values that are passed in as these parameters here, pointing to our source string and our destination string. So we stepped over them, and we can see that the source string actually is a constant char pointer to the method this is broken. Destination, is null. Okay, so the destination is null. Now the line of code that we're going to execute here dereferences the source pointer, which is going to grab the first character right now would be the T, convert it to uppercase using the toUpper C method that's built into the C standard library, and place it into C destination. But C destination is null. So what's going to happen is, when I step over that, like so, we got our segmentation fault. The reason we got a segmentation fault is, while we are initializing these variables that I am passing into this method, I'm not actually allocating any memory for them to copy into. So I have a pointer that's pointing at nothing. That pointer that's pointing at nothing, when we try to dereference it and write to it, causes a segmentation fault. So how do we get around this? Well, I'm going to show you two different ways we can get around this. The first and easiest way is I can just create or initialize this here actually as an array instead of a char pointer. The other thing I could do is I could use dynamic memory allocation on the heap. Now, memory allocation on the heap, what we use is a method called malloc, memory allocate, that's going to allocate a buffer on the heap. And then we can pass that pointer in to the given piece of code. The amount of memory that I want to allocate is going to be the length of the string that's typed in plus one character, where that one character is added to indicate the null at the end of the string. So, how can I do this? Well, let's read in the string. And what I'm going to do is I'm going to malloc some space for the LC string. So, LC string, whoops, I got to type it right, is going to be equal to malloc strlen of the initial string, like so. Now, strlen is part of the C standard library. So what I need to do is I need to make sure I'm including the header file. So that is in string.h, which I can find it out by doing a man page lookup on the method strlen, calculate the length of the string, string.h. I also need malloc. Malloc standard lib.h. So I'm going to include standard lib.h. And I'm going to set that up. So I'm mallocing the string length plus 1 for the null pointer. If I malloc something on the heap, what I also need to do is, before I exit the program, is I need to free the memory. I'm going to free LC string. That will free the allocated memory from the heap. Because remember, C does not have garbage collection, unlike Java and some other languages. So now that I have fixed these two things here, I've got a problem in 2-caps demonstration. Oh yeah, I can't do that quite so easily like that because of the way this is assigned back like that. So what I'm going to do is actually cast this over to a void method and just ignore the return value that comes in, like so. We see that went away. Here we see it's getting assigned to it. Doesn't make a whole lot of difference. Both of these methods work in this particular scenario, either ignoring it or essentially passing it. Where it wouldn't work is if I was assigning to a different pointer than the buffer that I was passing in. But in this case, that's not the case of how the code works. So I've got those two fixed. Let's run this now. This should work well. Initial string, this should work well. Cap string, this should work well in caps. Lowercase string, this should work well, all in lowercase. So what we've seen here is essentially how we can go about debugging code by single stepping using this debug perspective here, where we can use either these buttons here or F5, F6, the function keys to single step, step over, continue running, so on and so forth. Pause execution. Our variables live over here, and we can see the different types and expand them as is necessary. We can see our code here. The other thing we can see up top here is our call stack. Okay, so this has been a demonstration of using the Eclipse debugger to single step and debug pieces of source code. That's going to bring this video to a conclusion.